Okay, so we're going to look at the practice worksheet for creating polynomials, and in numbers 7, 8, and 9, we're asked to write a factored form polynomial of least degree, and that least degree is important, that has the real zeros that are shown in the graph. Okay, so we're only concerned about real zeros. We don't need to wonder what's happening with any imaginary zeros. So in number 7, the first thing that I want to look for are those zeros. So here we have a cross, right? It's crossing straight through the graph at -4. So I have a 0 at x equals -4. Okay, then here at -1, I have another cross, so x equals -1. Okay, then it's crossing again here at +1, so x equals +1 is a cross, and at 4, x equals +4, right, we have another linear factor where it's crossing through the x-axis. So those factors are x equals -4 would be a factor of x plus 4. Right, x equals -1 would be a factor of x plus 1. X equals +1, that's a factor of x minus 1. And then x equals +4 is a factor of x minus 4. Okay, then we need to think about the leading coefficient, whether it's positive or negative. So when I look at the ends here of my graph, both ends are pointed up toward positive infinity, and so I know that this is a positive leading coefficient and an even degree polynomial, right, because of the end behavior. So if I add up my factors here, I've got linear, 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 linear. There's 4 linear. That's degree 4, which is an even degree. So that matches what I've got here. And I know it's a positive leading coefficient, so I don't need to worry about putting a negative in the front. And that would be my polynomial in factored form. That is the least degree with those 4 real zeros. Okay, now looking at number 8. Okay, we have 0 here at -2. So x equals -2 is a cross, so that's a linear factor. But then at +1, the graph comes down and bounces off of that x-intercept. And so that means that x equals +1 is going to be a bounce. And if you recall, bounces have even multiplicity. So it, because we want the polynomial of least degree, the smallest even number would be 2. So this factor of x minus 1 is going to need multiplicity of 2 because of that double root there that causes the bounce along the x-axis. Okay, then our factor of x plus 2, that's a cross, and so that's a linear factor. And our leading coefficient, since it starts down and ends up, we know that this is a positive leading coefficient and an odd degree polynomial. So y equals x plus 2 times the quantity x minus 1 squared. That is our polynomial of least degree that has those real zeros on the graph. Okay, so then looking at number 9, we see a wiggle here at x equals -5, right? And so x equals -5 is a wiggle through the x-axis, right? We can see that S shape wiggling through there. That factor then is going to have odd multiplicity greater than 1. That's what causes the wiggle. Okay, then we have here at x equals 1, the graph is crossing straight through, so that's going to be a linear factor. And then here at x equals 3, we've got another bounce, right? So x equals 3 is a bounce. That's going to have even multiplicity. So now when I put those things together, I have a factor of x plus 5. It's a wiggle, so it has odd multiplicity greater than 1, and since I'm writing polynomials of least degree, that means that my factor is going to have multiplicity of 3. Okay, then I have a cross here at x equals 1, so the factor is x minus 1, and it's a linear factor since it crosses. Then x equals 3 is a factor of x minus 3, but because it's a bounce, it's going to have even multiplicity, and we want the least degree, and the smallest even number is 2. Okay, and then we're going to look at the end behavior for the leading coefficient test. So this graph starts down and ends down, and that tells me that I have a negative leading coefficient and an even degree polynomial. So I need a negative out front here, and then I want to check that my degree is even. So 3 plus 1 is 4, plus 2 is 6, so this would be the equation of my polynomial of least degree that has the real zeros shown in the graph.